Okay? Huh? No, I'm leaving that for a second. Okay, so like with a problem like this, they said this is the easiest one because they tell you what's upper, what's lower, they tell you the boundaries, they tell you everything there. This would just be a matter of, in terms of setting up the integral, you put the numbers in the right spot. Such as, when I write this out, the a and b that I put on either end of the integral would be whatever the x's are that they say there, which would be 0 and 1. So 0 is the lower number that goes there, 1's the higher one. And again, when you set this up, this f of x, that needs to be your upper boundary. Like for the graph, this is the lower one. Which again, on this problem, they do tell you that, right? I'm not like forgetting, correct? They do say upper and lower, yeah? Yeah. Okay. And the upper one was e dx? Is that right? Yeah, so like in terms of me using the definition that's up there, f of x would be the e dx. What's the other one?
X.
Just x, and that'd be g dx. Or, I mean, g of x is x. So when I set this up, this will be like e dx minus x. Which again, like I said, like these integrals shouldn't be that hard because the integral of e to the x is e to the x. There's nothing really to do there. For the integral of x, you just got to do the reverse kind of power rule thing. So this whole integral should come down to e to the x minus, what's the integral of just x? X squared over 2. And then you evaluate that from 0 to 1. Okay, so meaning you take the 1 and the 0, plug them in, and subtract the 2. Okay, so this will become e to the first minus 1 squared over 2. So that's the upper value, and then you subtract it from the lower one. 2. So this would be like e minus 1/2 minus 1. Right, because e to the 0 is 1. Anything raised to 0 power is 1, and that's just 0, so I'm not including it. I guess I could include it plus 0. So it becomes e minus 3 over 2. You should get something, if you zoom in enough, that looks like that. That would be your x squared graph. All right, and then the other one should come up kind of like this. So you should have one intersection point that is going through the origin. That's at 0, 0, and then you'll have another one right there. Which means that the area they're asking you to find where these two intersect is this little bit right in there. Okay, so since I'm looking at this, this function right here, the other one, the 2x minus x squared, since it's going to, when it starts intersecting, passes above the other one, this is going to be my upper boundary because it's going on top. The other one going below, it's going to be the lower boundary. What's this intersection point? Can we get that? 1. It's y, yeah, that's all I care about. X equals what? 1. Okay, so when I set this up, I've got still from 0 to 1. Okay. It always goes as the upper boundary function first, minus 2x minus 2x squared. Again, both of these integrals, or both these antiderivatives for these should be fairly straightforward because they're just power rules. So this, whoops. What's the antiderivative of just 2x?
Oh, x squared.
X squared? Antiderivative of the other one is what?
2x cubed over
3.
We're out of the clip now. We just
Is that all right? Where it comes from? Everyone else, yeah? Yeah, don't say sure. Make sure you know the fact of where the heck it's coming from. Understand? Okay. All right. So again, it's a matter of plugging in the numbers now. All right, so the 1 would be, again, first, so 1 squared minus 2, 3. Just gonna throw a 0 on the other one because everything else cancels out. What's 1 minus 2/3? 1/3. Hey, there's your answer. The way this one is set up is, I'm gonna put a little dash line there. If I had this graph to scale, this would be 2 equal regions right here. This point where they intersect, if you actually graphed it out, would be at pi over 4, because this is the one point. This is where sine equals cosine in terms of like unit circles. So what you have is you have one region here, you have another one here. So this question's actually asking for this area and this one put together. I can't just go 0 to pi over 2 in this case, because of the fact that if I look at this from left to right, from x equals 0 to this point here at pi over 4, the function that's on top is cosine, and the one that's on the bottom is sine. And as soon as you get to this point, it's going to reverse spots. Now sine becomes on top and cosine comes on the bottom. If you have that happening, where this comes into play, which most of the time, guys, you're only going to run into this, I would assume, with the trig. It's not the only situation it could come up in, but I don't think you guys will see it more often than that.
Can you explain one more time why we're not finding the area in the middle one?
What do you mean?
Like why aren't we
This
doing-
part isn't
yeah.
bounded by both of them. Because when they're telling you that it goes from this line here, x equals 0 is this vertical line. So it has to come in contact with that vertical line, not in here.
Wow.
Same thing with this part here. They're telling you x equals pi over 2, so it's got to come in contact with that. Okay? All right, so now again, I got to set this up as 2 integrals. Like essentially, this is technically what I'm doing. And again, the reason is because for this interval here, from 0 to pi over 4, I've got cosine on top and sine on the bottom. Whereas the other one is going to be reversed. Okay, and they aren't necessarily going to give you the exact same intervals. All right, at least like antiderivatives. The values should be the same. The periodic, they should be equal things. All right. What's antiderivative of cosine? Sine. So this is sine x, and antiderivative of sine is negative cosine, yeah?
Yes.
So plus cosine x, 0.4. And then the one on the bottom should be negative cosine x minus sine x from pi over 4 to pi over 2. Sine of pi over 4 is square root of 2 over 2. Cosine of pi over 4, square root of 2 over 2. Sine is 0, 0, and cosine is 0 would be 1. Okay, so you need to remember these right here. Those will always be expected for you to remember. Okay? So this is square root of 2 minus 1. This one down here, when I plug these in, cosine pi over 2 is 0. Sine pi over 2 is 1. If you forget all these guys, you better at some point take the time to try and remember them.
Awesome.
Yeah. Very good. All right, so cosine pi over 2 is 0. That's 1. Whoops. Shit, what am I doing? Square root of 2 over 2. Minus plus 2. Would be the area of the first region. That's the area of the second one. And to get the total, you would just add them up. So you get square root of 2 minus 1 plus negative 1 plus square root of 2, which should be 2 square root of 2 minus 2.